Good afternoon everyone, welcome to the channel. In today's video I want to implement a machine learning algorithm which is called HistGradientBoostingClassifier. Hist meaning histogram based. So this algorithm comes with Scikit-Learn and it uses histogram based techniques to aggregate features into discrete bins or histograms. Then it processes these bins instead of individual samples. This algorithm is quite handy for dealing with large datasets. So the difference with the gradient boosting classifier is that it doesn't deal with individual samples like gradient boosting classifier. Rather, it deals with aggregation of features. So let's get started. So at first I want to import required libraries. So import pandas as PD, then import matplotlib, then from HistGradientLearn so HistGradientLearn.preprocessing import label encoder, then from HistGradientLearn.model selection import train test split, from HistGradientLearn.ensemble so import HistGradientBoostingClassifier, and finally from HistGradientLearn import matrix. Sorry, something is wrong. Okay, now let's load the dataset for this example. So I will use a dataset which is called letter recognition. Okay, so pd.read csv. Okay, so this is our dataset. So we have quite a number of features. So these are the features. These are different values by which we can recognize different English letters, X box, Y box, etc. And this is the target column. So these are capital English letters. Let's check the shape. So it says 20,017. So we have 20,000 rows, 17 columns. Among them 16 are features, and the last one is the target column. So let's now check the unique entities in the target column. So I think these are the capital letters in the English alphabet. Let's see. So 1 2 3 4 5 6 7 8 9 10 11 12 13 and 13 in the bottom row as well. So we have got 26 letters. let's also check the value counts. Okay, so 813. So each letter is present well over 700 times. It looks like. Let's also check. So df dot is null. Is there any null values? Looks like there is no null values, so 0. Okay, so it's good. But the last column we do not have any numbers, so these are all categorical characters. These are numerical, so we need to deal with that. So let's perform preprocessing. So label encoder. Let's check df.head again. Okay, so now we have 198336 instead of 𝐇𝐢𝐬𝐭𝐆𝐫𝐚𝐝𝐴𝐴. So we can just confirm by running this line again. So let's just check A and Z. So if we use this label encoder, then these values will be mapped with numbers starting from 0, and since we have 26 letters, that means it will finish at 25, 0 to 25. So in our case, A will have a value of 0 and Z will be 25. This is the last part before A. Let's check how many. Okay, 7 before A. So A will be the 8th one. 1, 2, 3, 4, 5, 6, 7. So this is the 8th one. So A is 0 and the last one is 25, which is Z. Okay. We can also confirm this one as well. So A is at number 5. Sorry, number 6. Before A there is 5. And Z is at the bottom. So is Z. So we got 25 here. And 5 after 5 we have A. So 789 A and 734 Z. Okay. So we have performed preprocessing successfully. Then we can just separate features and classes. So tf.ilog. So we are just dropping the last column, and here we only select the last column. So only difference is the column. Then we can split the data set, do train and test. So xtrain, xtest, ytrain, okay. So we have 20,000 samples in total. So because of 20 and 80% split, so I think we'll get 4,000 test samples and 16,000 train samples. Let's check. So this line confirms that 16,000 training samples and 4,000 test samples. Now we can use our machine learning algorithm. So HistGradient let's call it histGBC. Let's see what are the parameters available. Learning rate, max iteration, max depth, none. So many parameters. Okay, so I just want to change this one. I also want to set a random step. So by default learning rate is 0.1, but I want to increase it a little bit. Max depth is none. So let's say 4 and random step 1. Then we feed our training data on it. Xtrain, 𝐸train. Okay, it took a little bit long because we have a lot of samples here. Maybe it took a little bit more than 1 second. So now we can just check the accuracy. So this is the test set. Okay, so the accuracy on the train set is 0.9964 or 99.64% and 95.53%. Okay, not bad. So let's plot confusion matrix. So 𝐸predict dot predict next test. So 𝐸test, then 𝐸predict display labels histGBC dot classes CMap on color false, text KW, size will be 15. Okay, then figure. Dot okay, then add the labels. This is prediction, this is oil label, this will be ground truth. And this will be confusion matrix. Okay, and let's run it. Okay, the picture is too big because we have 26 entities in our target, so it starts from 0 to 25 and on x-axis and y-axis both. But let's make the window size a little bit smaller. Still big enough. Oh, become too small. Okay, I think we have fitted it somehow. So you can see that in most of the cases we got, not most of the cases, in all the cases we got most of the predictions correct. You can see the diagonal, in the diagonal the numbers are much bigger, and we also got a few wrong predictions here and there. You can see 1, 4, 3, yeah, etc. So because this accuracy is actually high enough, we got this kind of confusion matrix. So now what we can do is we can replace 0 to 25 with A to Z, which will make this confusion matrix more appropriate. So let's increase the window size again. Okay, so we can just copy this part, paste here, but before that we also need to add a list. Okay, so now we just need to type the letters from A to Z. W, X, Y and Z. Okay, so we have 26 letters here. Then instead of this we can just add these categorical labels. It should work. Okay, now we have A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay, so basically it's the same plot like this, but we replace these numbers with letters. Now let's print classification report. So we got precision recall F1 score values for each digit. Looks like all of them are above 90. Okay, so it looks alright. So one final thing I want to do is I want to compare the performance of this algorithm with 𝗏𝗏𝐺BM, because in the documentation of Scikit-Learn I noticed that it was mentioned this algorithm is developed from the idea of 𝗏𝗏𝐺BM. So I want to see how 𝗏𝗏𝐺BM performs on this dataset. So import 𝗏𝗏𝐺BM. You have to install it separately. It doesn't come with Scikit-Learn. So I have installed this version of 𝗏𝗏𝐺BM 4.5.0. Let's just copy and copy this part. Let's call it 𝗏𝗏𝐺BM. Okay, so let's check its parameters. So it also has a learning rate of 0.1 by default, but I will keep this value fixed. Next step is -1 by default. Random state is none by default. Okay, so looks like it will work. Okay, so there is a condition -1 by default and maximum pre-depth for base learners less than equal to 0 means no limit. Okay, so but if setting this to a positive value, consider also changing num_libs to less than equal to the power max depth. Okay, so num_libs is integer 31. So 2 to the power 4. 4 is the max depth 4. Okay, so less than equal. Sorry, this is not the correct. This is the 2 to the power 4. So 16. So that means we have to add another. Let's call it 16. I think less than equal is good enough. Where is that condition again? Okay, num_libs to less than equal to the power max depth. So this is equal of 2 to the power max depth. So let's remove this and let's run this on. I think everything is kept same to this one. I think 0.241. Okay, let's run it. Okay, so I want to avoid this warning. Looks like it's too big. Also, this problem occurs every time. Okay, so let's reduce it to 12. Again, we're getting this warning. 10 is still warning. 9 Okay, looks like that warning is gone. Okay, then finally copy these two lines. So I will just remove this GPM .94 and 95.35. Previously I got 99.64, 95.53. Let's copy this and sorry. So this is the hist gradient boosting classifier 99.64 and this is the light GPM 99.94. Oh, so there is not much difference in the training accuracy 95.35 and 95.53. So there is not much difference here also. So I think this can be used as an alternative of light GPM classifier because the results are not much different. Okay, so I think that's the end of this video. Thanks for watching.